Hello everybody. In today's experiment we're going to be looking at properties of chemical bonds. In chemistry there are three basic types of chemical bonds. There's metallic, covalent, and ionic. And all of their properties are based on how the electrons interact between the atoms in those bonds. Usually the properties are a result of the way that the electrons are used in the bonding process. For example, metals conduct electricity because the electrons in a metallic bond move constantly or are delocalized throughout the sample. That movement of electrons can create an electrical current, which then can be used to make wires and be used in electrical processes. Now, many of these properties you can just tell by looking what kind of bonds might be in them. For example, metals are shiny. Ionic substances are crystalline. And covalent, they can be solid, liquid, or gas. And those are properties, again, that are the result of how the electrons are shared or transferred or moving. In this lab, not only will you be looking at the different substances, you will be also seeing them being tested for the properties that you can't tell just by looking. So you'll learn about their melting points, you'll learn about their solubility in water, and you'll also learn on their conductivity of electricity. You will have 7 unknown substances, and when you are watching them being tested, take down the information and use a list of properties that your instructor gave you to try to figure out what types of bonds are in the unknowns. So we're going to get into the lab, and I'm going to show you a series of tests that are used to describe what kind of chemical bonds are in which substances. Okay, so here we have all the materials for testing the types of chemical bonds that are in different unknown substances. They are labeled A through G. We have some water on the right. We have some scoopers. We have some watch glasses so we can do our mixing and our dissolving there. Some pipettes. And this item right here is a conductivity tester. So when it conducts, the current will be completed. There's 2 wires on the end. And then when it lights up, then you know it conducts. So we're going to be testing both the conductivity dry and then dissolved. Because remember, ionic bonds have a unique property where it doesn't conduct as a solid, but it will conduct when dissolved. So we're going to get set up and we're going to do some really quick tests to see whether any of these have ionic bonds or covalent bonds. Okay, so according to the instructions, you take about a pea-sized amount, which is about this much. This is A, by the way, in case you can't tell. There's A. All right, and as you can see, if I can get a good close-up of this, you can see what it looks like. And if you really look close, let me see if I can focus this a little bit better, then you can see what we got here. All right. So what does it look like? Remember, ionic is crystalline. Covalent, they look kind of powdery, kind of, dull, whatever you want to say there. So then we'll test the conductivity. Now, if it conducts, then you'll see that it lights up. I'm touching the wires here. So let's watch what happens when I put them in. And as you can see, it's not doing anything. So dry does not conduct. Now, does it dissolve? So what we do is we get some water, and then add some water to it and see what happens. Okay. Add a little more just to make sure. It says to add about 5 or 6 drops, but let's just make sure. And then you mix it up a little bit. As you can see, some of it is going away. So that tells you that it does dissolve. Ionic substances tend to dissolve in water. So now let's test the conductivity wet. And as you can see here, it lights up when you touch the wires in it, and they're not touching normally. So this conducts as it dissolves. I'm going to do the same set of tests for the rest of the unknowns. And remember, this is A, so make note of that in your lab notebook. The same tests were performed on unknown B. Please note the information about the melting point and the odor on the ticker below. You can see here, as a dry substance, there's no conductivity. And when we dissolve it in water, you'll see that it dissolves a little bit, but it does dissolve. Okay? And then we check the conductivity as it's dissolved. And as you can see, the light turns on. As you observe unknown C, you'll notice it does look like it might be crystalline, but it's really hard to tell sometimes. Just make your best guess. Again, check the information at the ticker, and as you can see here, it does not conduct when it is a solid. And then when you dissolve it in water, you can see it is a little slow, but it does look like it dissolves. And then we check the conductivity when dissolved. Okay, the wires touched there, that's why the light went on that time. Unknown D is unusual compared to the previous solids that we tested. As you can see, this is a blue solid this time, and that's why we have it on a white background, so you can make your observations more easily. I'm not going to make any more commentary about what you see here in terms of the results. For the remaining solids and other substances, I want you to try to do the same thing. But I want you to notice that as it dissolves, notice the color of the solution. Now this one does take a little bit of time to dissolve, but notice the color of the water around it. You can see it has a bluish tint. And that's going to be a good indicator of its solubility as well. Unknown E is a liquid. Now, in order to gauge the solubility of a liquid, what you have to do is look at the state of the liquid after you mix it with water. If it looks like there's a bubble or layers forming, then it doesn't dissolve. If it looks like one complete layer after you mix the water, then you can assume that it is dissolved. So take a look and see what happens after some water is added. As you can see, it looks like it mixes evenly. One of the downsides of our current situation with the way school is running is that you can't be in person to see some of these tests. I hope you've been noticing the odor, and as you can see here, this one has a strong odor. It is very pungent, and I know in years past, whenever I have done this experiment with other students, several students have actually asked to sit down after smelling this stuff. So, although you can't really see the odor, it is very strong. So you can take my word for that. This is our last unknown, unknown G. Again, hopefully you've been keeping track of the melting point information and the odor information. If you missed any of these, then of course feel free to rewind and watch again and make careful note of the data that is being presented to you in the ticker. Alright, that was a lot of tests that were performed, but hopefully this gives you a better idea of what kind of bonds were in those substances. Now, remember, as you observe some of the properties and reflect back at your data, you might notice that some of the properties kind of overlap. One of the crystalline substances had a very low melting point compared to other substances of its type. So when you make a final decision as to what kind of bonds there are, consider that there might be one or two properties that don't quite match up. Well, what do you think you have to do then if you have a list of properties and one or two aren't quite what they should be compared to the rest of them? How would you figure that out when it comes time for you to decide what kind of bonds are in it? Ask your instructor for some help. Also review all the property lists and make sure that you make a really clear decision as to which is which. Also, you might want to review the video again to catch some of the information about the melting points and whether or not the substances had an odor. Because remember, having an odor is a unique property to one of the three types of bonds. So, again, it does not match seeing it in real life, but hopefully you get a good understanding of the kind of tests people perform whenever they have a new substance they want to decide what kind of bonds are in it. So thanks for watching and have a good rest of your day. Remember, talk to your instructor if you need any help or to help you decide what kind of bonds are in each of the substances.